Welcome to Radar Communication course. Today we start here a first topic, that is Model 1. What is the radar equations and what are the radar basics there? So to start with a radar, we should know that what do you mean by the radar here first. And then if we continue the discussion about their equations and their types of the radars there in detail. So radar, that word radar, if you see that, if you okay find out the meaning of this radar there. So radar means what? This is about what we can say that are a terms that is used here for the radio detection, okay, radio detection and ranging. Now, if you see here, I have just used a marker here that I am using a marker and I have just mentioned that it is in a bold one, okay, that capital letter. So this one R A, this is a D here, this one is a capital A, this one is about A. So R A, this is for a D here, this is for A and this for R here. So that is about your, what we can say that a radar, radio detection and a ranging. That is about a noun. Name comes from. Why we can say that a word radar here. So radar is nothing but what? It is that this one is useful for the detecting as well as for the ranging. Detection means what? Object detection. Ranging means what? To find out that what is the place of the object, position of the object. Okay, detection. Okay, so whether that object is present in the given region, that is to be detected by the given that device, and ranging, that is to measure the what will be the place or what will be the position, whether it is in a coordinate system, xy coordinate system. Okay, what will be the measurement, distance measurement there in a various coordinates. So that is about a radar here. So generally a radar, if you see that, it is nothing but a device, and that device is transmitting one signal. Okay, so if you see that we have a device, okay, this one is about, suppose I am saying that this one is about a radar here. Okay, so this one is about our device. So it transmitting the electromagnetic pulses to a object. So we supposed to consider that object is nothing but your aeroplane. Okay, so right now we just see that this is nothing but a aeroplane here. Okay, so now this one is about our aeroplane here. So now it just sending the pulses or a signal to the object, that is about a aeroplane. And then what happened, this object will reflect that particular signal frequency. Okay, so it transmits a electromagnetic signal. Okay, it transmits a electromagnetic signal to the object. This object is nothing but a aeroplane there, and then object will reflect those electromagnetic waves. And then the role of a radar here, it find out what will be the distance from the radar to the object there. Okay, here. So our aim is about to find out the what will be the range there. Okay, that is about a range. Okay, or a distance from this whatever the transmitter here. This one is a transmitter and to the object. Now we say that here that object reflecting the wave. Okay, object is reflecting the wave. So this object is nothing but what? It is a metallic one. Surface is a metallic one. Okay, so metallic surface, as we have seen that the properties of a microwave signal, the signal microwave signal will reflect from the metallic object. Okay, so already we know that a microwave is signal frequency range is in terms of a gigahertz, 300 megahertz to 300 gigahertz. So now that particular frequency, micro frequency range, that is to be used in a radar. So which frequency band is used by the radar? Okay, same that frequency band that you say earlier in a micro frequencies there. So same micro frequencies signals are used here in a radar. That is about 300 megahertz to a 300 gigahertz. So mostly, if you see the radar, what are the various frequency bands? So then there is some a frequency band, and then there are some uh, frequency ranges that is useful for what purpose, that is mentioned in the frequency band table there. Okay, So we can go through that particular table. So that's why we need to know about that electromagnetic band of a frequency is there. Okay, so what are about the electromagnetic band? So already we learned that a electromagnetic band, we say that it starts from the high frequency. Okay, so it's about HF1, and then we can say that that is about the end at the what you can say that a higher um, frequency, that high frequency to the what you can say that a millimeter waves. Okay, so generally we say that a high frequency band is from the 3 to 30 megahertz. So now above that, whichever the remaining band we have, okay, so that is about, we say that it is about a 3 to 300 megahertz frequency band. So whichever the remaining band is there, 3 to 30 megahertz is about high frequency. Then we can say that VHF is about a 30 to 300 megahertz. So I'll just write here the band of frequency that is about the HF. We say that is 3 to 30 megahertz. Then very high frequency VHF, that is about a 30 to 300 megahertz. Okay. Then UHF, you can say that UHF is about what you can say that a 300 to a 1000 megahertz. Okay. Means 1000 megahertz means what? We can say that it is about a 1 gigahertz. So now this one is about the range of frequency from this, from the UHF band, that is about a 300 megahertz. From this to, we can say that a millimeter wave, that is about a 300 gigahertz. So we can say that a radar will work from what we can say that a 300 megahertz to a 300 gigahertz of a frequency there. Okay, that is about a frequency range of the radar, in which band. Then we can say that a L band is about 1 to 2 gigahertz. Then S band, that we can say that a 2 to 4 gigahertz. Okay, so then C band, that is 4 to 8 gigahertz, right? Then X band, 8 to 12 gigahertz. So this one is about a micro frequency band that we have used in a practical or in our lab. We have this X band devices with us, that is waveguides that are work in a X band there, that's about 8 to 12 gigahertz there. Then a KU band, 12 to 18 gigahertz. Then K band, that is about 18 to 27 gigahertz. Okay, I hope that you people are able to see this. Then KA band, then 27 to 40 gigahertz. Okay, then above that we can say that a millimeter wave, or you can say that people are saying the name is about V band, that is 40 to 75 gigahertz. Then W band. Okay, then W band is about a what you can say that a 75 to 110 gigahertz. And then that is about a millimeter wave or millimeter band here. We can say that 1102 is 300 gigahertz. Okay, so now these are about the frequency band. Okay, so in which frequency band your radar is used here? Radar is using from the 300 megahertz. This is about it. A 300 megahertz, you can say that we can use that radar from the 300 megahertz. Okay, to the this one, to the 300 gigahertz. Okay, that is about the frequency range. Okay, so now, so what exactly, so pulses, what exactly the signal is transmitting by this radar there. Okay, so generally we can say that radar is used in two types of signal. It is about a pulse signal or a continuous wave signal. So now, if you consider that which signal is to be used by the radar, okay, so pulse or we can say that a continuous wave, and based on that there are the types of radar. Okay, radar types. These are the types are based on the what types of a signal to be used by the radar there. So that's why we can say that a whatever the input signal, Based on that, we can say that a types of a radar there. So generally, we say that it is used a pulse signal. Okay, so we can say that a pulse radar, or we can say that a radio frequency used by the radar. It has a pulses there, or a sequence of pulses. Sequence of pulses means what? We have a various pulses. So likewise, these are about the sequence of pulses that is to be used by the radar. And another is about what we can say that a continuous wave. But okay, these are about the a continuous wave in which we get that radar transmits a continuous signal. Okay, so we know that a continuous signal how it is to be transmitting there. Okay, so that is about whether it is in the form of a square wave, or we can say that it is in the form of a, okay, so whichever the waves format. Okay, so format. So so just generally we can say that it is about a continuous one. Okay, so now we can say that there are these are the basically a two types of radar. We can say that a pulse radar, or a we can say that a continuous radar. Then based on this, whatever the repetition of a pulses are there, okay, according to that, and the use of this radar, so there are the various types of radar, or we can say that a radar rangings are there, and that are useful for the different applications. Okay, so we will go here in detail about that, what are the various applications and the purpose of those various radars there. And if you see that the radar can see the various objects, that objects present in a day or a night. Okay, generally you can say that it is useful for the detection of the object. So that object can be in a, we can see easily that object whether it is in a night or whether it is in a day here. Okay, so whatever we can say that everywhere, every time, any time, if, even if there is a fog, there is a rain, okay, there is a snow, there is a cloud, okay, so even if there will be a land or something else, okay, whichever the objects are there, that can be seen in the any places or any environmental condition. Even if supposed to be there is a fog, okay, that fog, that doesn't matter with whatever the frequency signal. Okay, so we can see that radars can see the object whether it is in a day or night, it is whether it will be a rain, whether it will be a sun, okay, shiny timing, okay, or whether it will be that object whether it is present on a land, or whether that object is present in a air, or it is present in a cloud. Okay, so likewise, so we can say that this device will use to see or identify the objects from any place there. Okay, so this object cannot be hidden. If we are using a radar devices, so objects will not be hidden. So objects can be found from any places there. Okay, but except that the condition is different here. Okay, if supposed to be the subject, some objects are there, they are present behind the good conductor. Okay, so that why that objects could not be seen. Okay, clear means again we can say something related, because if it is a conducting one, again that uh, depth of penetration of a wave will come in a picture, and then whether that wave will be absorbed by this, or with what you can say that uh, it will be absorbed by the surface. Okay, and how much will be penetrated. Okay, so then another issue will come, so we'll not go here, but we usually say that a radar will identify the various objects present in the on a planet there. Okay, so it could not be hide, that the objects cannot be hide if we are using the radar there. So now from this radar we are able to get the what is the position of the object, position in the different coordinate systems and all, we can find out through this. Okay, so we can say that we are able to see the what is the position here. Okay, so what will be the position of the object there, or we can say that position, or we can say that we are able to find out the distance. So that is the body, we can say that a range there, or we can find out Even if the position, again along with that we can find out the what will be the size of the object there. Okay, so and then we can find out the what will be the velocity of the object. Then the velocity object, whether that object will come nearer to the transmitter or whether it will go away from the transmitter. So that's about it is the object. Okay, so means whether that object is stationary or a moving. If it is a moving, in which place it is moving, in which direction it is moving, that can be identified by this particular radar there. So means generally we say that we can find out one particular object, or we can define some particular target to the device, and then that target recognition can be possible through this different devices. So if you consider that, so in which region these radars to be used, so that's why they have the different applications of a radar. Applications of a radar generally, if you consider that, find out that where that object aeroplane, that aeroplane is there, in which what will be the velocity of that particular aeroplane. Okay, where that aeroplane is present right now, so that can be obtained. So radar can be used in a airborne application, radar can be used in a ship application. Okay, so we can detect or locate the ships where the, that ships are present. So yesterday I told you that this can be used to find out what will be the speed of the ball, okay, in a cricket or in a tennis also. So nowadays people are saying, even in a football, people are thinking about that. What will be the speed? Okay, that rate. Okay, so how much will be the hit by this particular? Okay, so that can be obtained through the various radar. Not necessary. We can choose that highest frequency. We can use a megahertz frequency also, and through that we can find out the objects there. Okay, so these are about the various applications or various use of the radar, and that applications or various use of the radar, the everything based on the what will be the frequency, operating frequency of the radar, and based on that, that radar is to be used. So now we need to talk about that. What are the basic types of a radar? Generally, we say that a radar can be used a pulse, okay, or whether it can be used that is about a continuous wave there. So according to that, we can find out. We can say that the there are the two types of radar. Generally, that is based on the whatever the signals we have. We can say that a two pulse two types of radar. Again, we can talk about that whether it is to be used a single device for the transmitting and receiving, or a two device for the transmitting or receiving. So according to that, there are the two types of radar. Okay, basic types. So basic types. One is about a monostatic. We'll see in detail monostatic, and second one is about a bistatic. So in a monostatic, what happens? We have the device. We can say that we have the radar. Okay. In that case, we say that we have a radar now. Okay. So now this one is about. We can say that we have a transmitter and receiver there. So this one is about our radar device. It has a transmitter and receiver there. And if supposed to be we have the object. Okay. We can say that we have the object. So you can the single device is used to transmit the pulse, and the same device is used to receive the pulse. And through that we can find out what is the place of the object and everything. Okay, so in that case here only the single device, okay, one device. So that's why we can say that a monostatic means the transmitters and receiver both are present in a device. Okay, that's about whatever we can say that a transmitter there. Okay, so that we can say that a if we can say that we are sending the pulse. Okay, we are sending the pulse, suppose. So I am saying that that pulse is transmitted by this radar itself, and the pulse is received by the this device itself. Okay, that whatever the device. So we can say here, so it doesn't have a separate antenna for the transmitter and receiver. It has a single antenna. It has a single antenna for transmitting the signal and same antenna can be useful for the receiving the signal there. So that's why we can say that this one is about a monostatic one. Okay, that is called as a monostatic antenna. Monostatic radar. Okay. Then we talk about the bistatic radar. But in a bistatic radar, what happened here? So we have the, suppose I am saying that this is about a object. Okay. So object is there in a space now. And then we have the transmitter is to be placed here. And then we have the receiver is to be placed here. Okay. So now transmitter and receiver. So there will be a difference. Means this one is a transmitting the signal and this one is a receiving the signal. Okay, so that is about a bistatic. Means a transmitter and receiver, okay, they are separated. Okay, transmitter and receiver, they are both are separated. So means one is transmitting one particular pulse and then another device is just receiving that particular pulse. So here this means, so this is about object. So location or identification of that particular object can be identified by this particular receiver, not a transmitter. Okay, only role of a transmitter just send a pulses and then receiver will receive the pulses. Okay, but it's not necessary this transmitter and receiver to be separated. Okay, too far. Okay, so it can be about be within a 1 kilometer of a range. It's not 100 kilometer, 400 kilometer. No. Okay, within a 1 kilometer of a range, or these devices can be nearby also transmitter. And receiver. Okay, but the role of this understanding of this bistatic, what you can say that bistatic radar. So in this case, it has a separate transmitter and a separate receiver. And the distance between this transmitter and receiver should not be greater than the, okay, that's about that's about 1 kilometers of something else. Okay, so we can generally say that in a kilometer there. So that generally we talk about that uh, whatever the range there. Okay, so more, nowadays if you see that the biostatic devices, okay, so they are using that whatever the radar they are using it in a aircraft as well as in a missile system. Okay, so ground system send the pulse. Okay, ground system send the pulse to the missile or to the air. Okay, so we can say that ground system send the pulse to the object, and the receiver can be at any place, or receiver can be placed in the aeroplane itself. Okay, likewise. So, or receiver can be placed in a missile itself. Then the distance between the transmitter and receiver will be larger. So, in that case, we can say that a bistatic device, so in which that range between the two transmitter and receiver will be greater than the kilometer. Okay, so it will be greater than that particular kilometer. Okay, always. So we can say that a device, if it is on the ground, so according to that, that distance will be different here. But if you consider that if it is that receiver is to be placed in the aircraft or a missile, okay, so in that case, then distance will be large. So generally, that radar is to be used in a missile, so in which we have that receiver will be there, and according to that, we need to send some particular pulse guide the missile. So that's why we can say that a guided missile technology. Okay, so and we have learned that various bands of frequency, and that band of frequency, we say that it's from the 300 to 3 gigahertz of frequency. But then the limitations of this band of frequencies are there. So what are those limitations? Limitations regarding what? If we supposed to use a low frequency signal, okay, if we are using a low frequency signal, then what happens? Then we require, what is the requirement? Then require large antenna. Okay, so why the low frequency? So already we talk about that antenna and their frequencies there earlier. Okay, so in that case, if supposed to we are using a low frequency, we require a large antenna, or we require a whatever the beam supposed to be provided by this device, radar device. it will be a larger beam. This one is about a larger beam. And a narrow beam is what? This is the narrow beam. This one is about a broader beam. Okay, so likewise, so we can consider that what will be the operating frequencies there. Okay, so according to that, we require a large antenna or we require a antenna that will provide a larger beam there. Okay, so that's why the limitations for the low frequency that are for the measurement of a range. We are not able to measure the accurate range there if we are using a low frequency there. So then what happened? We are not able to identify that what will be the transmitting pulse time and what will be the receiving pulse time. Then there will be differentiation in between the ambiguous range, okay, unambiguous range. Okay, so likewise, so we can talk about that in detail about that range equations and range measurement. So what will be the unambiguous range or what will be the ambiguous range? Okay, we'll talk about later. Okay, then if we supposed to consider that a high frequency signal. Okay, so right now we talk about that low frequency radar. And if supposed to be we are using a high frequency signal, so in that case, what happens for the high frequency signal? So that whatever the requirement for the antennas, okay, and requirement for the power, okay, that will be minimized there. Okay, so that's why generally we supposed to consider that a power requirement or antenna requirement as well as that accuracy of that particular range and everything that will be minimized if supposed to be we are using the high frequency radar there. Okay, so we talk about that later in a detail about that what is the requirement for the high frequencies and all this. So now we see first what is the unambiguous range there. Okay, so how to identify that a range equation that we'll see. Okay, you can say that talk about that a radar range or we can say that a radar measure. We'll discuss here first. What about the radar range there? Okay, so generally all the ranges, okay, most of the time if you see that they are supposed to be considered in the what you can say that in terms of a kilometer one. Okay, whatever the ranges we are. So we say that a signal is transmitted by the device. Okay, transmitted by the device. That can be a pulse. The same pulse will be received by the device. Okay, so now, so what will be the transmitting time of the pulse? Okay, this we I can say that we are transmitting the pulse at t is equal to 0. Okay, so that is and then at what time that pulse is received. Okay, so that with some particular distance time. So based on that particular time, we can find out what will be the range. And if supposed to be we are not able to identify that at what time that pulse is transmitted, then we are getting the unambiguous range. Okay, so we will see first what do you mean by this a range of the radar. Okay, so you can say that first we have a device now. I'll just write down here. This is about our device. You can say that we have a radar here. So it has a transmitting device as well as a receiving one, transmitting pulse as well as a receiving pulse. And this one is to be, we can say that we have the object right now. I suppose to consider this one is about a object. And then we say that we transmitting the pulse. About the pulse is transmitted to the object. Then this object will reflect the pulse. Okay. So in general phenomena, means we can say that it emits the electromagnetic signal. Okay. What is the role of a radar? It emits the electromagnetic signal. Okay, transmitting the electromagnetic signal, and that pulse, when it reaches to the whatever the object there, then it will be reflected from the object. Okay, so we can say that energy again reflecting back to the device here. So means transmitting pulse, here we can use any oscillator or any pulse generator. So it will transmit the pulse of the frequency, whichever the frequency selecting we are, and then pulse will be transmitted here. Okay, when the transmitted pulse is reaching to the device or this object, okay, means you can say that interception. Then what will happen? Then it will reflecting. Okay, means we can say that pulse will be reflecting by the object, means retardation of the pulse or retardation of the signal is expressed. Okay, means signal radiation and signal re-radiation. Okay, so you can say that reverse one. Okay, by this particular object. So what will be the pulse of the energy is transmitted by this device? Okay, that is about you can say that energy radiated toward the object and energy re-radiated by this object is reflecting signal. And then what will be the minimum level of the signal received by this device or understand by this device? Okay, so minimum acceptable signal. Okay, that level. So we talk about that level of the signal. Okay, lat. So right now we talk about that range. So how much is the time required to transmit the pulse toward the object there? So that is about generally when we talk about the measurement of the range. So generally we need to talk about that timed email, whatever the time required for the transmitting the pulse. Okay, time required for transmitting the pulse. So that's about it. We transmit the pulse from this. So how much will be the time required for the transmitting the pulse to the this particular object? Okay, and that object is having some particular distance. We say it is about a r now. Okay, that is about a r is a target. Target from what? From the radar to the whatever the object we have. That is about a r is about a distance supposed to. So in that case, when we transmit a pulse, then what will be the time required to transmit a pulse toward this particular object? That's about a whatever the t out we say. So t out from this particular object, okay, from this particular object, from this radar, it transmit one particular pulse, and it will be reaches to the object. It is defined in terms of a r by c. So generally what happens? What will be the pulse time required for the transmitting pulse to travel to a target with a distance of a r? So means we need to know about the what will be the speed of the pulse. Okay. So the generally what we can say that RF energy or whatever the electromagnetic energy that will be travel at the speed of a light. So that's why it is about a c. C is nothing but 3 into 10 raised power 8 here. Okay, this one. C is nothing but what? 3 into 10 raised power 8 meter per second. That is about a transmitting pulse. Then a time required to revert back this particular signal. That is about a tau back. What will be the time? So that time back is equal to what will be the range here and what will be the C here. Okay, so that is about a time back. Okay, transmitting whatever the signal there, and we are then total round trip time means transmission as well as the reception of that particular pulse. So then we can say that a T total is equal to whatever you can say that what will be the round trip time required for this is equal to we can say that T out plus back here is equal to twice of R by C. Okay, the what is C. And then from this we can find out a range there. Okay, so range can be calculated. That is about a R. Range can be calculated R. So how much is the time required for transmitting and receiving pulse there? Okay, that's about a round trip time. So we can say that T R tau R here. Okay, so that's why we can say that is divided by a 2 here. That is about a range of the radar here. Okay, so generally we can say that whatever the pulse we are transmitting is about, we can say that pulse is transmitting pulse. Is supposed to draw here now. I'll draw here. So this is about a pulse transmitting now. Okay, this one is about a transmit pulse, and we are receiving some particular pulse here. One. So this one is about a receiving pulse. So that is about what you can say that this is the distance that we can call it as a tau r here. Okay, tau r is nothing but what? A transmitting pulse and a receiving pulse here. That is about a distance. This one is about a transmitting pulse. Okay, so that is nothing but what? A what you can say that twice of r by c here. This one r is equal to twice of r by c. Okay, so that is about a, a range. That is about a range we can calculate here. So we stop here. So thank you all of you.